detail, but let's go ahead and welcome them to the stage so they can have their 2 minutes set up. Our next team is Smart Arm. So Smart Arm, if you can make your way to the stage, you have 2 minutes to set up. And again, ladies and gentlemen, welcome back. I know it's been a little bit of a delay today, but the weather has definitely gotten better. We still have the international teams coming up, and I can tell you, if you're excited about the national, it just gets more and more exciting in the international category. With all the submissions that we've had and where we are today, you're guaranteed a great show. So Shabat, let's talk about this next team who is setting up. They're going to have their 2 minutes to set up, but what can you tell us about this team? They're called Smart Arm.
So Smart Arm have built one of Dubai's first 3D printed bionic arms. We did have a team a little earlier, but they had composite materials. What the team over here have done is a lot of their project is actually completely 3D printed, and there's very, very good reason for that. They're able to customize the arm for absolutely any kind of patient, because it's a medical device, so it could be a young person or it could be somebody old, and obviously every human body type is different. And that's the main reasoning behind using the 3D printing technologies. You can basically map someone's, let's say there's an amputee, you can map their arm, and that allows you to build a prosthetic that is custom for that particular person. And they can even change the motors, swap out the electronics. For children, if you want to lift heavy objects, they can put bigger motors in there. And they're controlling this wirelessly. They're also they're the second team, national team we've seen today that are using the EEG technology. So they've got an emotive EEG headset which allows a person to wirelessly control this arm. And there's also a very, very good reason they're doing that. Normally prosthetic arms and biomechanical devices require a lot of training, so you'd have to have maybe sometimes surgery done to get it working. In this case, it's completely non-invasive, so you just put on the wireless headset and off you go.
Excellent. Now the audience has been great today. I see a lot of familiar faces who were here in the morning. I think we want to get some of them maybe on our fan cam, so we're going to point the camera in your direction. You might want to get your phones ready, because as soon as we put you on the screen, you might want to take a picture of yourself and send it back home. We're going to do that for you right after the next team, all right? So get those smiles ready, get your phones ready. Don't forget the hashtag today is UAE4G, in case you're on that social media. Next team, ready to go. Please put your hands together for one of our 2 remaining teams. This is Smart Arm. You have 15 minutes.
Smart Arm. It all started as a graduation project in Ajman University, but we wanted to take this idea to the world for the people that could benefit from it. We are simply 3 graduates from the Biomedical Engineering College, but we have a vision of changing the world. Who we are? Allow me to introduce ourselves. My name is Muhammad Ajam, Walid bin Nasi, and Ubaida al-Najjar. Let us take you on a ride on why we kept working on this idea, or in other words, the problem that inspired us to continue our journey, and what solution did we find to solve this problem, and of course, the live demonstration of our project. So, what problems causes amputation?
3.3 million of people in the world does not have the hand. It's a big number. It only looks, by looking, even if you look at, it's a really big number. So imagine, in the world, 3.3 million of people without hands, surviving somehow, not leading a normal day life. Let's get back to UAE. What happens in UAE? UAE has the highest rate of diabetes. In statistics, UAE rates number 1 for diabetes. That's because maybe the lifestyle over here or something else. And secondly, the cancer. It's the 3rd leading cause of death. In even cancer, you need amputation. In diabetes, you need amputation. So, we're looking at higher risk of people getting amputated in UAE. Secondly, according to the United Nations, 196 countries, only 10 are not fighting any war. So, even if you look at these statistics, We have a lot of soldiers who are getting injured, who are sacrificing their life for us. So we have to even deal with them. And secondly, the accidents, injuries. Nowadays, it's a very common thing. Accidents during car, motorized accidents, sometimes also require amputation. So it's better to give them a better solution. As you can see in the graph, the red line is the UAE. It's really high in the diabetes. Now, every solution exists. Every problem has a solution because people are working on them. But in this era of technology, you don't want something which is simple. You want something that is state of the art. One of the solution, that is EMG, electromyography. This solution uses muscles to control your arm, bionic arm. But what happens is, some of the people who are born without hands, who have deformities, does not even have muscle signals. So it's like you're leaving them out. But no, we have the better solution for them. Second solution also comes as invasive. So over here we're looking at the elite class because invasiveness requires a lot of money, a surgery, rehabilitation courses, and also sometimes it will not have infections. That is also not a good solution. Pressure arm is a very simple solution. You apply pressure, your hand is going to contract, you release pressure, your hand is going to relax. So that means this is a simple solution. But in this technology or era of technology, you don't want a simple solution.
So why we are doing this whole thing? Besides that, really want to win the 1 million dirhams. But we have some reasons to continue that. The first thing, we have talked to some amputees, and we have found that most of them have lost their confidence. And that's what we are trying to do here. Not only to bring back their arms, but also to bring back their confidence and their self-esteem. And to do that, we have to give them an arm that looks exactly and also functions exactly as the natural arm. Another reason why amputees have lost their confidence is because they need a help in doing a normal daily work. And that's what we are trying to fix here, is to make them independent and get rid of that help of anybody. Also, not only doing daily work, but we want them to be part of building the society. After talking to them, I found that a lot of them have great ideas, creative ideas, but not because they have lost an arm, we just keep them away of the society. And of course, we are giving this to the soldiers that might have lost their arms, sacrificing their lives. So, what's our solution? Our solution is an EEG-controlled, 3D printed bionic arm. I know that's confusing, but here's the explanation.
So what is an EEG? EEG is electroencephalography. Brain is a very, very complex organ, sending signals at 431 miles per second. That's even really faster than the car. So imagine sending signals at such a higher rate, and you need to capture those signals, and you have to know which signal is coming from which part of the brain. So EEG does that. As you can see, I'm wearing one. That's a simple, comfortable EEG. Second part of our project is the motors. These motors can lift up to 14 kgs. Now each finger lifting of 14 kgs, around 5 fingers you have, you can lift 60 kgs easily. So this bionic arm is also strong. 3D printing is a new technology, it's a state-of-the-art technology that is also going much better. Now, we have shown you how it works. EEG, the signals are acquired from the brain. They are being transformed into the computer, signalized which signal is for what, and then sent to a processor called Arduino. This Arduino also has connected motors, which will sense which signal is it receiving and which finger it has to move. Over here, fingers are the motors also. We started also with EMG. The one you see in the picture is EMG, which is working. But as I mentioned before, EMG is not a solution for all, whereas EEG is a solution. Now, I've told you how it works. Let's take you to how the 3D printing works.
Regarding to the 3D printing, we select the most advanced technology to manufacture our hand. It's made from the material called PLA, which short of polyitic acids. It's a biocompatible material. It composed around 73 pieces, separated pieces, printed separately. It took around 144 hours to print all these 73 pieces. For assembly, it took 2 days to assemble those 73 pieces and together, then put the motors, tension them together. At the end, the final touches for the cosmetic overview, we put filler coat, then we put paint, then we put primer coat. And the 3D printing gives us an option that we can print any shape, any size, depends on the patient requirements. And now we're gonna show you the live demonstration for the hand, how it's worked.
Okay, ladies and gentlemen, you have been waiting all this time, and here it is. We are going to show you our live demonstration. We have planned that we can bring an amputee here with us to help us do the live demo, but unfortunately he's not here for some personal reasons, so I'm sorry for that. But as you can see, Walid was wearing the headset the whole time, so we will do that on him.
This is not 3D printed. Hello? Yeah. So this is the hand. You can see it's easily 3D printed. The fingers have full mobility, full rotational, and I'm going to control it with my brain, sending commands to it. We're going to do a different signs.
He can control the fingers by his toes. And also he can do different moves. This is a contraction, a full contraction and relaxation. And that depends on what he thinks, and that will be on the hand.
So you have seen that I can control simple movements. And these movements we stored because these are the most common movements. You're holding something, you're contracting your whole hand, or a minute thing you're holding, you can control like this, or something from here. So these are the most used hand commands. We can add more, that's not a problem. That's easily added more. You can add the whole finger, single movement. You can move the single finger, then second finger, then third finger. That's very easy to be moved.
So let's see what's our project advantages. First of all, what makes our project special, or let's say a product that amputees will buy? We put the economic constraints in our priorities because not all the classes can afford the high-cost bionic arm. Biocompatible, as we mentioned in the 3D printing, it's made of a material that is biocompatible and it will not make any infection or harm to the human body in any way, even the headset or the bionic arm. State of art, we printed in the 3D printer, or we manufacture it in the 3D printer, so we can adjust it any shape, any size, depend on the patient need. Non-invasive, it not requires any surgery or any implantation inside the human body. So we are getting out of the harming the human body or the infection. Customizable, as we said, we can customize any shape, any size, depends on the size of the patient, and easy wearable for the amputees. The amputees can wear the headset and the hand independently. So, our future plan to add, for this project, to add temperature sensor and pressure sensor. We all know that any amputees, they don't have any sensation for the bionic arm. So we are trying to give them a simple sensation. For example, for the temperature sensor, we are planning to put one sensor in the middle of the hand that indicates the hot and cold objects with two LEDs to let the amputees know that he is holding hot or cold objects to not harm the hand or harm himself. Wrist movement is one of our future plans. It is now have a wrist movement, but we are planning to put a full rotational wrist movement will be better than the human arm. Wireless connection, now it is wired connection, but with only the laptop. We are planning to put software on the mobile, so there is no any wires between the head and the arm. Rechargeable battery, is it a rechargeable battery now? But we are looking for one small, strong battery to let it be use it for a long time. Yeah, around 25 hours. And we are doing our best to give it a natural look. For example, if the amputees was a kid, so they prefer to his hand to be like some favorite heroes. For example, Iron Man or Spider-Man or any heroes. So we can do the shape that the kid wants.
Okay, ladies and gentlemen, who we are? We are Smart Arm, and we are directing thoughts into movements. It's the end of our presentation, but of course it's not the end of our journey. And thank you.